Da 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 da. Da, 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 da. I realize all these 80s action shows are really unfair, but I'm your teacher and I get to pick the shows that I love, so yeah, deal with it. Let's do probabilities of the normal distribution. We're going to do nap time for 2-year-olds. You put a 2-year-old down for a nap, on average, they're going to sleep 2 hours. Now, when you see the normal curve, I hope in your mind you draw this in your head, and right here in the middle is where we're going to put the 2. But what goes right here for the standard deviation? It's not 1.96. Did you catch the trick? It's not squared. This 1.96 is really 1.4 squared. That's our standard deviation. Watch out for that trick. Don't get fooled by it. So here's our distribution. Now, we want to know what's the probability that a random child sleeps more than 3 hours. This is really important for the sanity of parents, because if you can get 3 hours of actual productivity, which means you'll probably sleep the whole time too, that can be such a big deal. If this is 2 and a standard deviation is 1.4, 3 is going to land right about here. So when I say what's the probability of sleeping longer than that, I'm looking for this area. Just guessing, eyeballing, I really actually don't know. I would say 30%. There's my guess. How do I find out? First step, I'm going to do the z-score. Z says, how many standard deviations away is this? It's less than 1 standard deviation, because 3.4 would be 1 full standard deviation. I'm going to take 3 minus 2. 3 is what I want to know. 2 is my mean. Over that 1.4, that gives me a z-score of 0.7143. In the homework, 2 or 3 decimal places is about right. Don't get fooled into thinking this is the probability. Look at our picture. 71% is not the right answer. And if you took 1 minus to get the other side, it's still not right. This is a z-score. To find the probability, we're going to go to the applet and put in 0.7143, and there is our probability. Nope, that's not right. I need to flip the sides. Thank you for the picture. Always draw the picture. My probability is 0.23752. Now, what happens if we ask the question, what's the probability they sleep at least 3 hours? Well, it's the same, except we're going to include the value 3, which has no area. Don't get tricked by this. It doesn't matter if it has the equals or not. It's the same answer, 0.23752. What if I ask the question, what's the probability of it being between 1 and 2.5? Well, I can do the picture easy. Between 1 and 2.5 would be like this. I'm going to take an eyeball guess again. I'm going to say 30% again. Last time I was only off by 7%. That's not bad. So we're going to do 2 different z-scores. Okay? You can't combine it into one z-score and solve this problem. I need a z-score for this guy, which is negative 0.714. Notice the negative telling me that I'm below the mean. Here, I do it for the 2.5, and I get a positive 0.357. I'm going to put each of these z-scores in my applet one at a time. You can't do it once. This is 2 questions at once, so 0.714. There's the area I get from there all the way over. What if I did 0.357? 0.357. There's that area. So how can I go back and forth between these two and find the area between? From 0.357 and over, it's 36%. From negative 0.714, it's about 76%. Can you see that the difference between those 2 areas would give me my answer? 76%, subtract off this 0.357, subtract off this 36%, that would leave me what's in the middle. This one gave me an area of 36%. This one gave me an area of 76%. If I subtract them, I'll get my 40%, which is the right answer. I was guessing 30%. I was a little low. Last time was a little high. Now, there's other ways you could do this. We could have flipped both sides, and then we'd be subtracting this area minus that one. It doesn't matter. Keep it consistent, and you'll be okay. If you did this one to the left and that one to the right, now you're mixing things up. Don't do that. Be consistent. Always going left or always going right if you're trying to find the areas in the middle. Let's talk about the probability of x being greater than 12. In other words, what's the chance that your 2-year-old is going to sleep more than 12 hours for his nap time? Don't you wish? Look at our picture. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's right here. I'm not really going to write on my wall, but I'll bet you can guess what the probability is going to be. Based on the normal curve, how much area do we have from that point on? Well, if we do our z-score, this comes out to be 7.14 standard deviations. 7 standard deviations out there. This isn't going to surprise anybody. 7.14. Oh, look, the probability is 0. The chance that your toddler is going to sleep more than 12 hours, no chance, according to the normal distribution. Now, to be fair, there would still be some probability, 0.000000000. You know what? We're just going to round. We're going to call that 0. Once you get so far out in those tails, you're either going to have 100% probability, if we had said sleeps less than 12 hours, or 0% probability for being beyond that.